Hello everyone, welcome to this channel MLGURU. My name is Arjun Pukare, and in this channel you will find videos related to topics of machine learning and deep learning. So let's get started off with our first video titled What is Machine Learning? So the first definition of machine learning was given by Arthur Samuel in the year 1959. He defined machine learning as field of study that gives computer the ability to learn without being explicitly programmed. Okay, now machine learning is a subset of AI, okay, as you can see in this diagram, and deep learning is a subset of machine learning. Many people confuse themselves with machine learning and deep learning as two separate things, but the truth is deep learning is actually a subset of machine learning, okay, and we will in further lectures we will see what is deep learning too, okay. Now, this is some more standard definition of machine learning as given by Tom Michel. He defined machine learning as a computer program is said to learn from experience E with respect to some class of tasks T and performance measure P. If its performance at task in T as measured by P improves with the experience E. Now to explain this definition, I will give you a simple example. Suppose you have to learn Python and you have started today learning it, okay? Now this is your very first day you are learning Python. So do you expect yourself to become pro on the very first day? Is it so? No, right? As you invest your time in it, as you gain experience, your programming skills in Python will improve, right? So this definition is trying to tell that if you have some task T and if your performance measure on it, which is denoted by P, improves with experience E, then this is called as machine learning. Now let's try to understand the key difference between traditional programming approach and machine learning approach. Okay, so this diagram depicts traditional programming approach in which we give two inputs. The first input is the data and the second input is the set of rules. Okay, now imagine you are writing a function, okay, you are defining a function. So while defining, you write some set of rules, right? And this data is given as input to this function. Now based on this data and set of rules, you get some output. But in machine learning approach, you have one input as your data, but the second input to the model is the output which you desire to get. Okay, this is something little weird for you, for the beginners, but this is the key element of machine learning, that you give the output which you expect from the model as input for training. Okay, so based on this data and output, you get some set of rules. Now as you have got this set of rules, you can use these rules to make some prediction. And machine learning is all about making predictions. Okay, now let's consider this task. This task is to classify an image whether it contains a picture of a cat or not. Okay, so suppose I tell you to write a traditional program to classify this image as cat or not. Would you able to write it? Now traditional programming is nothing but set of if-else blocks. Okay, now imagine, okay, you have succeeded in writing this long piece of code of if-else block to classify an image of cat or not. Now what if I change this image, or I capture this the picture of this cat from some different angle, or if I change some color? Now will this same piece of code identify this image as cat or not? No, right? It will be a very tedious job and very inefficient. So this is what we call as explicit programming, which is very inefficient in our case. Now in machine learning approach, what we do is we gather some bunch of images. Some pictures contain cat and some does not contain cat. And with each image we attach the true label whether this image contains cat or not. And this bunch of images is given as input to our machine learning model. Now our machine learning model will go through this bunch of images and will find some pattern by itself to identify cat or not. Okay, now after learning these patterns, we will use this model for making predictions on unseen images. So isn't it amazing? Now let's look at another example. In this example, our task is to identify whether the patient is infected by coronavirus or not. Okay, so suppose there is a doctor and he wants to write a program to identify the patient has infected with coronavirus or not. Okay, so this identification is based on some set of inputs which are nothing but features or symptoms in this case. Okay, so the symptoms here are fever, cough, breathing problem, and so on. There may be many such symptoms, and vomiting. Okay, so suppose the doctor writes this program, right? Now according to this program, suppose a patient arrives and he has only fever, so the program will return as not infected. Okay, the program will return output as not infected. Suppose another patient arrives and this patient has fever and cough, now this program will again return not infected, right? Now suppose another patient arrives and he has fever, cough as well as breathing problem, now the program will return as infected. Now you must be thinking that from where these rules came from. These rules are made from the past experience of this doctor, right? Now there is a possibility that there may be some complex combination of these symptoms which may lead to coronavirus, but the doctor does not know about it. So this is the big limitation of this traditional programming approach. Okay, now let's see what is the machine learning approach to solve this problem. Now before giving this data to our machine learning model, we must first pre-process it to a specific format. Okay, now our machine learning model understands only numeric data, so we must convert our data into numeric form. So for that I have converted our data into this tabular format. Okay, this table contains some columns and some rows. Now each feature is denoted as a single column in this table. Okay, and each row here denotes a single patient. Okay, if you look at the first row, the first patient has a fever, does not have cough, does not have breathing problem, and does not have vomiting. And this last column contains the true label of that patient, whether he is actually infected by coronavirus or not. So in the first row it is 0, means the patient is not infected by coronavirus. Okay, the second patient is, and so on. There may be huge amount of data. Okay, huge amount of rows. Now this data is fed to untrained model. Okay, initially the model is untrained. When we feed this data to this untrained ML model, the model trains itself using a learning algorithm. Okay, in upcoming lectures we will see what learning algorithm means. Now just remember that this model will train itself by this data. Okay, it will go through the data and find some patterns in it which lead to coronavirus or not. Okay, now our model is trained. Now as our model is trained, we can give inputs to this model and it will give yes or no as output. Okay, so for example, I give this array as input. Now this array tells us that the patient has fever, does not have cough, does not have breathing problem, does not have vomiting, and the output given by our trained model is 0, or the prediction is 0. Okay, means the patient is not infected by coronavirus. Now some other patient arrives which suffers from fever, does not suffer from cough, has breathing problem, and so on, and also has vomiting problem. Now our trained model outputs 1, which means our model has predicted that this patient is infected by coronavirus. So why machine learning is so successful today? Okay, there are 3 main reasons for this. The first reason is today we have huge amount of data in various forms. Okay, we have text data, we have image data, we have video data. Okay, we have various form of data like music. Okay, so we can use this data for our machine learning task. Now we have huge variety of models. Okay, researchers have came up with huge and large variety of models of various complexity, and the best part is we do not need to know the mathematical part of it. Okay, we can directly use use these various models for our machine learning task. And the third reason is fast and cheap computing devices. Okay, today the computing devices are becoming cheap, and we also have cloud services like AWS or Google Colab, through which we can handle complex data and do fast and easy computation. Okay, we can do heavy computations easily and efficiently. Okay, now when we are talking about a machine learning model, there are basic 6 elements to it. Okay, these elements are the data, task, model, loss, learning algorithm, and evaluation. Now in upcoming lectures we will talk about each block specifically. Okay, till then, thank you.